We're Pushpesh and Shravani, and our final project is on how neurons communicate with each other. To start, we made a diagram showing the journey of an electrical signal between neurons, as well as a short description describing this process. This helps the user visualize exactly where and how the electrical signals travel from one neuron to the next.
Great. Now we will discuss exactly how a neural firing occurs. Basically, a neuron is constantly bombarded with positive and negative charges. If the net positive charge elevates the membrane potential past the critical threshold voltage, sodium channels rapidly open, initiating the action potential. In this visualization, pressing play demonstrates how an action potential is achieved when sufficient positive charge is received.
Building on the first two sections, we created this diagram and description to zoom in on the specifics of what occurs in the synaptic gap between two neurons. We can see how an electrical signal triggers our brain's chemical messengers, neurotransmitters, to be released. If enough of these neurotransmitters bind onto the next neuron, it can make the next neuron generate its own action potential, propagating the signal forward through the neural network.
Finally, we connected these cellular processes to how brain encodes information. One of the most basic coding strategies is firing frequency. Stronger stimulus causes neurons to fire more frequently. Our slider demo shows this. Lower stimulus strength leads to less frequent firing and a dim light perception, while higher stimulus strength leads to rapid firing and a bright light perception.
This was an overview of how cellular level neurons encode and communicate complex information like brightness or locating a sound source. Thank you for watching this demonstration.